For centuries, farmers have used animals to help them farm. Horses, dogs, oxen, cats, the list goes on. But what if I told you that the farmer I'm visiting today employs the strongest animal in the world, and that creature is less than a centimetre long? Taurus, vaca, bison. These are words I heard a lot when I visited Gavin Sinclair on the family's 260-hectare dairy farm in Cooriemungle, and they are all words which relate to
So you got the Taurus will work through the summer and autumn, then we want the bison to take over in the winter, and then hopefully the vaca take over in the spring, leading back to the Taurus. So we just want that continuous cycle of an active beetle all year round, and you probably need half a dozen different species on farm to achieve that.
Yep, there's a clue in the names. Taurus, vaca and bison are the species names of 3 bovine dung beetles, all of which have been working on Gavin's farm. Their job? Again, the answer is in the official name. Taurus and vaca belong to the genus Onthophagus, which comes from the Greek for dung eater. But these fascinating little fellows do much more than feast on feces. They improve the soil by burying manure in it, by breaking it up and creating tunnels which encourage plant roots and worms. Their behaviour also improves water quality and filtration, increases available pasture area, reduces pest species and intestinal worms in cattle, and sequesters carbon. The list goes on. When Gavin returned to the farm in 2017, he became fascinated by the feats of these marvellous manure munchers.
Yeah, go down the paddock in the summertime and you see a cow pat there just with thousands of beetles, and you just sit there and think, well, that's pretty impressive. I wonder if we can, what's the story of the dung beetles?
Although less than a centimetre long, male Onthophagus taurus beetles can carry 1,141 times their own body weight. That's the equivalent of an average person pulling 6 double-decker buses full of people. Inspired by the hard-working taurus beetle, in late 2019, Gavin introduced another species. Bubus bison is a European beetle which was first released in WA in 1983 and is currently the deepest dung bunger in Victoria. It buries manure 60 centimetres underground and sometimes more. And that is the sound of 2,000 Bubus bison beetles at work, digging manure into soil inside a 300-litre storage facility. Thanks to beetle specialist Dr. Russ Barrow of Charles Sturt University for that recording. Now, back to Gavin.
So we got 50 beetles. We put them in a small enclosure in about June, and we found that they just kept burying. We just kept feeding them dung pats, every week or two, all the way through till November, and they just kept burying that dung down into the subsoil. So that was pretty impressive to see. And then we just wanted to see if the larvae would survive in our soil types and our dry summers and wet winters. So the larvae were supposed to emerge as adult beetles the following autumn, but they didn't. So we dug them up and found that the larvae were still there in the soil, in the subsoil, in their brood balls. And so we thought, well, they'd take 2 years in our cooler climate, which is not unnormal. So, but after the second year, they still didn't emerge. So we dug them up again and found that the larvae were still there. And now we're hoping that they're going to emerge on their third year. So, which can happen in cooler regions of the world, So they're looking pretty promising. They survive wet, waterlogged conditions. They just sit there in the mud and manure all winter if it's and they just keep burying manure.
And, in case you were wondering, the deepest dung beetle buriers in the world are from the genus Heliocopris. These giant insects push elephant poo over 2 metres into the earth. Gavin got his 50 bison beetles from one of Australia's most distinguished dung beetle experts, who I was lucky enough to meet in March 2022.
My name's Bernard Doube, Doube. I'm a scientist. I worked for CSIRO for 29 years as a senior scientist. I was in charge of the CSIRO laboratories in South Africa for 7 years, selecting and importing dung beetles, and then I worked on earthworms and on the biological health of soil, so microbes and that sort of thing. And then I left CSIRO and we started up our company called Dung Beetle Solutions International. And so we have worked on soil health primarily, but on dung beetles in particular for the last 20 plus years. Of course, the question is, why have we introduced dung beetles to Australia? And the answer to that is, well, that although there are nearly 500 species of native dung beetle, most of them are very poorly adapted at dealing with the dung of cattle and horses. So they're used to the dry pelletized dung of marsupials. And so George Bornemisza in the 1960s, a Hungarian scientist who was working initially with the Department of Agriculture in Western Australia and then with CSIRO for many years, proposed that we should import dung beetles from overseas. He was a Hungarian and he had noticed that in Hungary the pads disappeared. You never saw them on the surface of the ground, whereas in Western Australia where he was, they were, they were metres deep in dried dung poo kind of thing. And so, he initially went to Hawaii in the 1960s and brought in 5 species of dung beetle they'd been introduced into Hawaii by the USA Department of Agriculture to control a buffalo fly over there. And they hadn't really worked, but they to control the buffalo fly, and as they haven't done here in Australia in my experience, but they in Australia, they just to digress a bit, in Australia they've been enormously effective in burying dung, improving soil conditions, and controlling the bush fly, the pestilent bush fly that comes into southern Australia every summer, or used to, but it's hardly ever here now. So George went to Hawaii and brought in 5 species of dung beetle to the CSIRO laboratories in Canberra, and they reared them up in field cages, and after very, very strict quarantine procedures.
So, Australia's native dung beetles would rather deal with koala crap, roo poo and possum pellets. I can't say I blame them. To get rid of the mounting mounds of cattle manure, the CSIRO have been carefully introducing dung beetle species from Africa and Europe since 1965. There are currently 25 introduced species in Australia, and in case you're wondering, these beetles are not the cane toads of the insect world. Each species is so specialised in their choice of poo, they will not affect the native food source. However, 9 species of Australia's 500 native beetles have been observed dining on cow dung, and the copper-coloured Orthophaga australis seems to be partial to horse poo. The Taurus beetle was first released near Canberra in 1975, and after many other releases, is now well established across southern Australia and indeed all over the world. Nearly all the males have bull-like horns, which the beetles use in battles for mates. Once they have won a female, the male beetle's entire life is about pushing poo, though not necessarily uphill. Here's Bernard to explain the life cycle of a dung beetle.
The first thing it does, of course, is live in the ground as a larva, and then it comes out. And when it emerges from the ground, it flies, or almost all of the dung beetles fly, although there are certain wingless dung beetles that crawl around but they spread very slowly. But the flying dung beetles, which all of the introduced dung beetles that we've brought into Australia, they all fly. So they emerge and then they fly and they smell the dung. So then they land in the dung and then they feed, often in shallow tunnels until they've developed their eggs. So initially they feed on the dung juices. When they've got mature eggs inside them, then they dig a tunnel. Now I'll just talk about Bubis bison. That's this winter active one, which is one of the what I call deep tunnelling dung beetles. Very important beetle. So the female and the male work together to dig a tunnel. The female down below passing the soil to the fellow up top, and he takes the soil to the top. And when she's got to a certain depth, perhaps about 40-45 centimetres, she changes her mind and she digs a sideways tunnel. And then she passes that soil up to him. And when she's got a sideways tunnel about 12 inches long, somehow or other she communicates to him to start bringing dung down. So he brings dung down to her, and she packs this tunnel with dung. And at one end there's a little cavity in which she lays an egg, and at the other end there's a little cavity which she lays an egg. And when that's finished, then she starts digging again and digs another tunnel virtually parallel to the one that's underground. And when that's complete, then she signals that she wants dung to brought down, and so then she goes through it. And if you've got, say, one pair of dung beetles in a large dung pad, they can continue burying that until all the moist dung is gone. And in winter, because of the cool conditions and the often rain, the dung beetles can continue to bury a pad for, say, 3-4 weeks even. And I've had them at home. I gave them half a ton of dung to see what they'd do with it, and they continued burying that until it was all gone. The whole half a ton was gone, and all there was left on the surface was about 200 kilograms of clay that they brought up from down below.
So with the right beetles, half a ton of manure can be moved underground in just 6 weeks. Or to put it another way, one bison beetle can bury one cowpat in 48 hours.
So the bison produces this sort of sausage, if you like, with an egg at each end, and we call that a brood mass, whereas some beetles just lay a round piece of dung underground in a series of sort of little side tunnels to the main tunnel that goes down. And when it's a ball, we call it a brood ball. And but the larva, regardless of what we call it, the larva feeds upon the organic matter, not on the dung juices. It's pretty dry by then. So the larva feeds on it's got chewing mouth parts, and it's a great big bag of microbes like the gut of a cow, and that digests the cellulose and other organic materials, and that generates the energy that's required to grow the larva. And so, say with bison, it gets to a mature larva by 6 months. So the life cycle is that it breeds during winter. During spring, the eggs hatch, and then the larva grows, and by mid to late summer, the larva is mature, and then it can either turn into a pupa and then an adult, and then emerge that year, or some of them, in cooler climates, some of them stay as a larva for an extra year. And so there's a 2-year life cycle. So down at Timboon, for instance, it will be primarily a 2-year life cycle.
Gavin has acquired another 600 bison beetles since the original 50, but although they have been busily burying manure, they have not yet produced any offspring. Gavin has twice dug up the larvae, but the transformation into beetles has been on hold for over 2 years now, something which, according to Bernard, is not uncommon in colder regions. Hopefully, they will emerge as beetles this autumn after 3 years in their larval state. Beetles retail at about $900 per thousand, so Gavin wants them to stay on his farm. But how do you keep a small flying creature in one spot?
So with our trial plots, we're just keeping them in enclosed little enclosures, whether that be the top of an old corrugated tank and with some shade cloth fixed over the top, or just a drum cut in half with some shade cloth strapped down. That just stops them escape, and they don't tend to want to go anywhere if they've got plenty of manure to feed on, but it also stops the birds and foxes picking them off as well.
Ibis and foxes are the main predators for beetles here. Foxes can even hear larvae underground and dig them up. After acquiring his first Bubis bison, Gavin introduced another species of dung bunger.
And they've got a new beetle that they've brought across from, I think, the Mediterranean region. So it's a spring-active beetle called Ontophagus vacca. So it's a little small orange beetle. And so they chose about 20 farms around southern Victoria and Tasmania. And they just they gave everyone a small allotment of beetles, and that was just basically a little research program to start off with 50 beetles and see how many beetles that turned into by the end of the summer months. And we found we would start off with about 50 and end up with a few hundred. So they proved that they bred well. They're supposed to be a spring-active beetle, so they should emerge before the our bison, not the Taurus beetles that we currently have.
Although this European species, first released in Australia in 1980, bred better than the bison, Gavin's colony disappeared in 2021. Gavin reckons they escaped from their enclosure, but hopefully they are still working elsewhere on the farm. Meanwhile, he has ordered a colony of Bubis bubalis, which hail from Spain and France, and were first introduced to Australia in 2014.
The bison are considered winter active, so they'll go all winter, and we find that in our cooler region they still go into spring and almost make it to summer. So the bubalis go from spring into summer, so we want to try them and see if they will pick up the gap between the winter active bison and the Taurus beetles we have, and that will give us pretty much a year-round coverage of beetles.
Beetles are, it seems, in short supply. Gavin is still waiting for his bubalis, and in March he was promised a couple of thousand Geostropus spinninger beetles. These 3 centimetre long autumn-active European beetles can withstand a British winter, so they should thrive in Cooriemungle. By May 2022, he had only received 25 beetles, but these valiant little creatures are already burying at prodigious rates, a cowpat a week. Think how much could be buried with the full complement. Here's Bernard again.
Of course, the dung beetles were brought in to bury dung, but what we didn't know was the multitude of benefits that would flow from that activity. So not only do we get rid of the dung that fouls the pastures and so stops pasture growing, but also the nutrients in the dung are buried. Now with these winter active dung beetles that go down to about, like the bison, goes down to 40 to 60 centimetres, it's very clear that this transfer of nutrients down deep into the soil has had major benefits on pasture production in many situations. Of course, one needs to remember that improved pasture production is a response to some form of limitation in the environment. So, for instance, there mightn't be enough nitrogen in the system, and so if you add nitrogen, then you get a pasture response. But if there's enough nitrogen in the system already, then even though you add extra nitrogen, you don't get an additional response. So that's why in some situations the dung beetles have produced only a modest effect, and in other situations they've produced a major effect on pasture growth. In all of my experiments, I've found that there's been a 25% thereabouts increase in pasture production. Now that's a major increase, and the cost of introducing a colony of, say, winter active dung beetles is perhaps $900 for 1,000 beetles, and they will multiply up over time to many millions in the local environment. And but the cost of that is, say, $900. But if you get a 25% increase in pasture production, it's like increasing the size of your property by 25%, and that would be a huge cost. So these things are highly, highly beneficial. I think one of the really important things about these beetles is the fact that they break in many situations in southern Australia. There is what they call a duplex soil, so you get a sort of a sandy loam over a clay, often a yellow clay, and the dung beetles in winter, when the soil's relatively moist and soft, they can break straight through that, but many other things don't, and so that barrier between the relatively infertile sandy loam on top and the highly fertile clay beneath, that barrier has been a major limitation. It's been recognised for the last 100 years as a major structural limitation to the productivity of the Australian agricultural systems. And here we have a particular device, the deep tunnelling dung beetles, that bash through that barrier and bring the clay to the surface, which the nutrient-rich clay, and take carbon and other organic matter, plant nutrients down into the soil profile. So the plant roots then follow these tunnels down deep into the soil through the sort of sand clay barrier, and it leads to a structural change, in a permanent structural change in the nature of the soil profile.
And as Bernard has discovered at one site, the improvement in soil is permanent.
Set up an experiment in 2003 and in South Australia, and we had soil cores in the ground in which we had dung beetles plus dung only and controls. And we found that in the first 2 years there was a major transfer of organic matter and carbon, of course, down into the subsoil. But the question was, well, how long did that persist? We knew that in the first 5 or 6 years there was a persistent increase in pasture production each year, but we didn't know what was going on underground, really. So 17 years later, my son and my grandson and myself went out to this paddock where we'd set up extra cores, because we just thought, I thought nearly 20 years ago that I might just come back and check it out one day. And so we did. And we found that when we pulled them up, the levels of carbon in the subsoil were still highly elevated. In fact, in the cores in which the dung beetles had been active. So one batch of dung beetles, one act of dung burial 17, 18 years ago, produced a permanent change in the structure of the soil profile.
Both Bernard and Gavin said that great care must be taken when drenching cattle, as this can kill a dung beetle colony. Dung from recently dosed cattle contains the poisonous substances which are lethal to the beetles, but also attract them to the pad. Gavin even warns against so-called dung beetle-friendly products. The Sinclairs have had an interest in sustainable farming practices for some time. Their tree planting efforts, effluent treatment ponds, and efficient composting system all testify to this. Even before becoming part of Heytesbury's Climate Resilient Farms project, Gavin and his family were planting multi-species pasture crops. For the Landcare trial, they chose a 3.8 hectare hillside paddock with a variable soil type but mostly heavy clay. The pasture mix included 9 different species, and Gavin showed me around in October 2021.
We'd already had a paddock that we'd put under a multi-species sort of cover crop style paddock, so we've sort of taken that paddock to include it into the sort of the trial work that's been happening, and just going to keep sort of driving that paddock down a different sort of approach. So we'd sown a paddock down with a multi-species cover crop in the I think it must have been 1st of December 2019. So it was a crop that was just directly power harrowed into an existing pasture with lots of chicory and forage rapes, tillage radish, millets, and they also had species in there like linseed and buckwheat and sunflowers, which are more there for beneficial insects instead of so much forage quality for milking cows. So the idea of that is to drive the crop as a bit more of a crop that looks after itself in the sense of providing habitat for wasps and stuff like that, which prey on your pest insects, and also all the different species sort of provide quality forage at different times of the year instead of just like a simple once-off grazing sort of method. It's going quite well. We're pretty impressed with the amount of feed that grew over the summer. We sort of come across some sort of hurdles in the autumn. We sort of sowed it down to another multi-species crop, but we just found that everything that was originally planted in the paddock just kept growing it into the summer and winter, and sort of nothing that we sown that autumn really took off too well. So we sort of had a little bit of a rethink of how we're going to approach the paddock, as in we're going to hopefully only sow it every second year and put enough diversity of perennials and annuals in there that will carry on for 2 years, and then just give it a slight top up with just something like annual ryegrass before the cooler months, just to get that paddock through the winter. Especially like the chicory and plantains, we're finding that their tap roots are going down a couple of feet into the subsoil, so they'll be bringing up lots of trace minerals and those sorts of things for the cows, and they really enjoy eating those forages. When the paddock matured a bit more through the summer and there was a lot of flowering plants in there was a huge population of hoverflies, lots of bees and sort of stuff. Insect life was just an absolute buzz of life in the paddock itself.
Gavin has always found this paddock problematic, so he's pleased that soil tests have shown a 1% increase in soil carbon in 2 years. In January 22, he planted a 1-hectare flat paddock with 20 species. On a farm open day in April 2022, 40 interested visitors, including myself, were treated to the sight of lush and colourful vegetation. The yellow blossoms of tall sun hemp and sunflower plants were interspersed with the blue of linseed and chicory. It looks like Gavin has got both beetles and plants helping to improve his soil. Generally, interest in the use of dung beetles is increasing amongst farmers, so hopefully there will soon be many more tiny international helpers on our southwest farms. On a more personal note, I'd like to see some dung ball rollers in action. At the moment, there are only 2 introduced species of beetle which roll balls of dung rather than tunnel, and both are confined to Queensland and northeast New South Wales. This is not surprising, as of all the dung beetle species, 20% are rollers and 80% are tunnelers. It's just that the rollers get more airtime. All the rollers belong to the genus Sisyphus, which makes total sense when you know the Greek myth. Sisyphus was a king who cheated death. The gods punished him for this by forcing him to continually roll a massive boulder up a hill, only for it to roll down every time it neared the top, for the rest of eternity. This is where you get the term Sisyphean, describing a futile task. But the work of these precious beetles is far from pointless. In fact, their behaviour has earned dung beetles themselves a prominent place in mythology. As part of the scarab family, they were sacred in ancient Egypt, but as always, it's the rollers which get the attention. The Egyptian god Khepri, an incarnation of the great sun god Ra, was often depicted as a dung beetle, because his job was to roll the sun across the sky each day. The ancient Egyptians believed that Khepri renewed the sun daily, before rolling it above the horizon, then carrying it through the other world after sunset, only to renew it again next day. So, the dung beetle was seen as a symbol of rebirth and regeneration, Surely a perfect mascot for regenerative farming practices.
Egyptian, walk like an Egyptian.